Hello, this is Mrs. Dowell, and I would like to spend some time today working on a difficult problem with you. This is completing the square in order to convert your equation from standard form into vertex form. Now remember, standard form is the ax squared plus bx plus c, and vertex form is the ax minus h squared plus k. I'm forgetting all about the y equals. All right, and then after we've done that, then we're going to determine if there is a maximum or a minimum value. So I would like to identify what is what first of all. A is -3, B is 6, and C is -2. Right off the bat, I know that my y-intercept is -2. Now we're not being asked to graph this, but we can't ignore some of the obvious things, that the y-intercept is -2. So I'm just going to jot that down over here. Y-intercept, 0, -2. Okay, so what I'm going to do is I'm going to replace f of x with y just to make it easier to work with. And then in the same motion, just like I did when I was completing the square to solve for the values of x, I'm going to move this constant number over to the other side. And I would do that in this case by adding 2. So this is going to be y plus 2 is equal to -3 x squared plus 6x. Please note that with each step, it is important that each new step is equivalent to the previous step, as well as keeps my equation balanced. All right, because there is a coefficient in front of the x squared term, which is -3, and I'll just jot down over here a is equal to -3, because that does tell us a lot about the graph of this parabola. But because there is a coefficient, I am going to factor out just that coefficient. I am not factoring out the greatest common factor. I am only factoring out the coefficient. So if I factored a -3 out from this first term, I would be left with x squared. And if I factored a -3 away from 6x, I would be left with -2x. So you may be wondering, how did I get that? Well, 6x divided by -3 is -2x. Okay? I'll put this in a bubble because I don't want this to interfere with our graphing information. Okay, I am now in a position where I have an incomplete square. The incomplete square that I have is x squared minus 2x. So I need to complete this square. And the process of completing the square is to take the b value, which in this case is -2. It is not 6. The b value is -2 here because we factored out a -3. So that affects our b value. So I'm going to take my b value, which is -2, and I'm going to cut it in half. That leaves me -1, and then I'm going to square it. That gives me +1. Now my next step, and this is the tricky one, I will be honest with you. The next step is to slide that inside of the parentheses so that I have a completed square. So x squared minus 2x plus 1. However, even though the right side is now a perfect completed square, my equation is not balanced any longer. Because what I did was I added 3 inside of the parentheses, but not realizing that really what I'm doing is subtracting 3. Negative 3 times 1. So on the left side of the equation, I would want to keep my equation balanced by subtracting 3. So once again, if I slide a number in right here, it is being affected by that negative 3. And that's what I did. I slid this 1 in side of the parentheses in order to make this expression a completed square. However, in the process of completing this square, negative 3 times 1 is negative 3. I must minus 3 over here on the left. So now I can clean up a little bit. Positive 2 minus 3 is negative 1. And then I'm going to come over here and take a look at this. And some people are always asking, why do I even need to do this? Isn't there another way? Of course there's another way. You can always use the minus b over 2a and get your x coordinate and then plug it back in order to get the y coordinate if you wanted the vertex. But the directions here said use completing the square to put this equation from standard form into vertex form. Well, the reason why I completed the square was because this is now a perfect square. It is now very easy to factor. I'm looking for two numbers that multiply to be 1 and adds to be negative 2. That would give me negative 1 and negative 1. Multiplies to be 1, adds to be negative 2. So as you can see, this completed square factors into x minus 1, x minus 1. So instead of writing x squared minus 2x plus 1 over here, I'm going to write what it is in the completed square form. Negative 3 x minus 1 squared. There's my square. Y minus 1. Last and final step is to move the 1 back over to the other side by adding 1. So my final equation would be negative 3 x minus 1 squared plus 1. In looking at this equation, I can see that it is now in HK form. I can easily identify what the A value is, although I was able to do that from the very beginning. I can easily identify what my vertex is. The vertex is H, which is 1, and K, which is 1. So my vertex is 1, 1. I also know that my A value is negative 3. That means this parabola would open down. And I also know the y-intercept is 0, negative 2. So I am going to take just a moment and sketch a graph of this. Vertex 1, 1. A value, negative 3. Y-intercept equal to negative 2. 0, negative 2. Let's see if we can use these three pieces of information in order to graph this parabola. 1, 1. That's my vertex. Y-intercept is 0, negative 2. A value of negative 3 means I go to the right 1 and I go down 3. It just so happens that the y-intercept is the mirror reflection of the rate of change point. Remember, if A is negative 3, you'd go to the right 1 and down 3. That gives you an idea, an immediate idea, of what this parabola is going to look like. If you need additional points, you can always make a table of values and plug in some additional points. I would probably plug in x equals 2, x equals 3, x equals 4. Not too many points are needed whenever you're graphing a parabola. Okay, then finally, to answer the question, is there a minimum or a maximum? Since A was negative, that means that there is a maximum y value at 1. I should say at y equals 1. If your parabola opens up, you have a minimum. If your parabola opens down, you have a maximum. I hope this has been helpful.